Okay, back to our lesson. So yeah, here actually if you see, oh, let me just, all right, well, this up here and just wait. Okay, so yes, let me remove this. Okay, I just removed the reading AI. Okay, so here we see, we have calculated the conditional distribution for status A. So yeah, here actually I made a mistake. So yeah, what happens here is actually they want us is into the each level of students. Yeah, they want us, yes, they want us for each level of student, meaning we want to calculate relatively. So 240 divided by 4,000, yes. Remember, because they are saying conditional distribution for straight A statuses. Straight A status not relative to the row. They want us relative to the well, relative to undergraduate students. So yes, here we want 240 relative to 4,000. So yes, 200 for the four. Well, it was 240 relative, yeah. That's about 6%. Yes. So there we go. That's how we get 6%. If we see 60 relative to what's column over there, yeah, that's 500, right? So 60 by 500, yes. 60 by 500, that's how many people got A's out of the non. How many, yeah. How many graduate students got straight A's? Yes. That should be about 12%. So yeah, 12% should be over there. Now here it actually should be like 100 minus 96. That is 94. We go to the next one, that should be 200 minus 12, which is about 88. Yes. And that's how they got this answer. There we go. Okay. So when we on this conditional distributions, what can we say about the association between student level and the straight A status? Yes. Here we can actually conclude is that if you see here, graduate students are more likely to get A's, right? Compared to themselves. Whereas because you are actually comparing it graduate and graduate. So based on their for each level of students, we are getting the straight A statuses. Like out of undergraduates, how many get A? Out of graduates, how many get A? We are not saying something like how many out of straight A's are undergraduate or how many out of straight A's are graduate. We're just saying how many out of undergraduates are straight A's. So that ways we want to model it. So we try to see here, try to think here a little bit. You're just going to kind of ruminate about for this. So 6 and 12. 12 is actually greater than 6. So that ways graduate students are more likely to get A's. Okay? It means graduate students are more likely to get A's, undergraduate students are more likely to not get A's. It means yes. Graduate students are more likely to get straight A's and undergraduate students are exactly right. There we go. Okay. But this college is direct association between the level of student and whether or not the students are straight A's. Actually, well, yes, we could say right. There we go. I can explain. Yeah, graduate students are more likely to get straight A's than undergraduate students. So yes, that means there is an association. Okay, it's not something like equal. It's not something like 5%, 5% for each. Otherwise, it'd be like if 95% got no A's, 5% got A's, regardless of whether they were graduate or undergraduate. Both are 5, 5, 95, 95. That way, that would be a relationship, there would be an association to tell whether the student has really got an A or not. That way, so we kind of need know the relationship by the different percentages. The differing percentages that gives us this. That gives us that kind of understanding that yes, there is somewhat relationship. Otherwise, why is this greater than that? Okay, here, quiz two. So each day of Spirit Week at our school, students have the option to dressing up according to a different theme. Tuesday of Spirit Week, I like regarded the students at his class, a school by class and style of dress. Here is the data. All the data up here now. Which graphic distribution is shown below? Okay, now this one is actually shown for dress for Spirit Week dress normally. So this one is the conditional distribution or marginal distribution. Well, this one is actually showing marginal, right? It's just showing two things: whether they're dressed for Spirit, whether they're dressed normal. That's it. Which means marginal. Marginal for type of dress. Exactly. For style of dress. Perfect. Mavis is interested in whether military dependency related to gender in the American. So yeah. So yeah, they're just saying like females and males, either kind of related to gender or not. Military dependency. Because males are more likely to get into military, so it's kind of model that relationship whether it's that and gender imbalance or not. So here's some data about the population of American Somia in 2010. And that's just saying for the relative frequency, marginal distribution of gender. Yes. Relative frequency, marginal distribution of gender. Now here is actually pretty simple because here we don't need to, set into any conditions. We just need to see how many are males, how many are females. Okay, how many males out of 519? It's about. So we just actually use a calculator up here. This Khan Academy calculator. Let me see. I think it's shown right. Yeah. Okay. So we just kind of toggle this calculator up here. Now he does to see it's 27, 23, 49. Oh, I think I can type in my keyboard. I just need to type like here. So 27, 349 divided by what's the division sign? Yeah, there we go. Divided by 55. Finally, finally. Okay. Okay. This one is actually 49 point something. Okay. This one is actually, so that means about like 49.26. That is about whole person. So 49, less than 49 are females. That means actually 15% should be male, but well, I'll just test about here. So 28. Was that here? 28 months only. Oh, what did it do? Wait. Okay. Yeah, 28. There we go. Oh, I'm sorry. I'm sorry. I think I just. Okay. 28, 170 divided by. What? Okay. Yeah. Okay. So like, probably that. 28, 28, 170 divided by 51519 is going to be 50.7. That is about 50%. There we go. Okay. So actually, it's kind of like a pretty good balance. Okay, between the genders, like 50-50 is kind of nearly. Now here James is interested in relationship between weather conditions and whether the time trains on heat runs on time. So this one is basically saying that whether the downtime train does it run on time or not. That's we want to see the relationship between. So basically, if you see here, let me close this. Yeah. Basically, if you see here, the results are displayed in the table below. So which of the following predictions will be correct? When the weather was snowy, it was more likely for the rain to be later than on time. Yes. When the weather was snowy, it was more likely to be rainy. Yes, that is actually correct. Given that the rain was on time, the weather was more likely to be sunny or rain. Yes. When it was rainy, it was yes, that is also correct. The most delays never occurred on snowy days, they occur on rainy days because 15 is greater than 12. So yes. A and B makes the most sense. Okay. Here's a table giving the demands for thousands of commuters in Alabama. So this one actually we have done before. We just took a look at the table, right? In Alabama, they're just commuting by no transportation methods and one way length of commute is being given. They're saying uh what is the marginal distribution of transportation methods in counts? Okay. For this one, actually, you're asking percentages, you're asking counts. So in counts, private vehicle, how many are going private vehicle, regardless of the transportation time? Well, 1887 are going private vehicle. 1887. How many going public transportation? Public transportation are going is 9,000. And here, actually, how many going? 42,000, right? Because 42,000 are using other methods. Maybe like bicycling, walking, animal carts, or anything. We'll be using. Yeah. Okay. Meriwether is collecting data about the kinds of and pursuit of mass from his clients. Here's some data. So here's some data up here on the screen. That's what is best distribution of the distribution. What's the best description of the distribution box in the last column of the table below. So here we see this is just totals. Totals means it's the marginal distribution. It's not conditional. Conditional means it should be summed on a condition. This marginal because marginal means it's like just for the variables. Okay, how many store repeater regardless of whether they were dogs or cats. Whose path source was straight? Whose path source was shelter? Whose path source was family or friends? Regardless of the animal, regardless of the cats or dogs. So marginal of the path source. Yes, that's actually absolutely correct. Yeah, kind of not better dog because if that would be the case, 170 and 115 would be the marginal distribution of kind of pet. That is saying 175 dogs, 115 cats. And we're just saying about the pet source, not about the pet kind of pet. Yeah, there we go. Next unit test. Okay, let's take a unit test as well. So today, so teams in the National Football League in America are divided into two conferences, AFC and NFC. Some teams have animals as the mascots and others not. So some have some like animals, some do not like as mascots. Variables is showing the displaying the data. How many teams are in the NFC? NFC, how many teams are there? Let's see. Well. Animal. They're 8 and 8, right? So 8 and 8 plus 60. There you go. Now, researchers once surveyed college students on their Facebook use. So they're surveying other college students how much Facebook they use. Two-way following table is showing all the data up here. They're seeing of students in the sample, how much fraction were in the 23, were in the age, what in the 23 and above age category. Okay. How many were there in the 23 and age? So if you see, 23 plus is how much? 130, yes. 137 out of 290, yes. 137 out of 290. There we go. Okay, now principal of a school held a vote to figure out which subjects students like the best. We got the information in the paragraph below. So just doing writing, reading, math, science, all of this subjects, and they're saying how many were votes. So they're basically I think close to five, right? This is between four and six. Five people are like writing. Nine people are like I think how many? Nine people like this thing. Reading, yeah, reading. This is nine, this one. Math is how many? 12. Math are like by 12 people. And then science has been like by science lovers are like eight. So we like math nerds are 12, science nerds, science lovers are 8. Writers are 15, and then reading are okay. So which of the shows the information on the bar chart? Okay. This one should be now writing is 5, reading is 9, where math is 12, science is 8. That means it should be the first one. There we go. Yes. This is just matching all the data. We know we got collected like five number of votes and nine number of votes, 12 number of votes, and eight for all the post checks. Okay. Here. School in New Zealand collect data about the employment status of the mother and father in two-parent families. Two-way column, sorry, of column relative frequency. So column relative means this is going by column. We can only say if the father is working full time, that means out of the father working full time, 23% of the mother are working part time, 10% are the mothers working full time. Okay, that's because we can conclude from here. We can say if the mother is not working, that means from there we can conclude about all of this. So given that the mother is not working, maybe 60% of the fathers are working full time. So there are more fathers who are not working, given that the mother is not working. Well, that doesn't make any sense, right? Because if we try to see this correlation, we can say that if the father is not working, in that case, is 80% of the mothers, given that the father is not working, 80% of the mothers will not be working, 13% of the mothers will be working full time, 10% of the mothers will be working part time. But we can say, given that the mother is not working, the father, like 80% of the fathers will not be working, right? So that's like column value frequency. Column value means we can just based on the column. So given that this column is true, this is this. We can say given that this row is true. Here we can say column is father is working full time. Okay, father is all the column, mother is all the rows. So take a look here. It's only data which the following statements must be true for the two parent families at school. Okay, here what we can conclude is that given that the father is working full time, most of the mothers will not be working, right? And if the father is working part time, actually, yeah, more mothers would not be working. So, given if the father is working, actually, this kind of counterintuitive, right? Because if the mother is actually, if the father is not working, the mother should be like, maybe working more. Because they would be like worried about the household expenses and stuff. But here it's kind of counterintuitive. But if the father is not working, the mother is also that much less working. Like here, if he sees kind of, downward going trend. When father is not working, the mother is less likely to work. Okay. And so if father working full time, then the mother is more likely to work full time compared to the other cases where the father is working part time or not working. So we see here, without the following statement must be true for this one. So if you see, family where the father working part time is twice as likely. Well, this one is actually a family where the father works part time. Okay, this one means that father works part time. Okay, so that one is saying is twice as likely to has a family is twice as likely as a family where the father is not working to have the mother work part time. Wait, what does this mean? So a family where the father works part time is twice. So this is I think more likely. Wait, works part time is twice as likely as a family where the father is not working. So yeah, mother would work part time more. Well, excuse me. This was actually correct, because we open 14. Oh, I see, okay. So they're just saying, mothers would be more working part time if the father is working part time. That ways maybe they get encouraged or something, but they work more part time. So it's twice as likely for them to work part time given that the father is working part time. Yes, that is actually correct. That's actually correct. It's most common for the parent to be working well. This one we can't conclude because we don't know how many families are there total. Okay. So we can conclude like how many most common will be there that the neither parent is working. We could definitely say if the father is not working, given that the father is not working, it's most likely the mother is not working. Okay, based on this data, like 80%, it's almost like 4/5 of the mothers are not working. But if the both parents are not working, that we can't include because we don't know how many families are there. So we can't say it is most common. If they're not like numbers, if there are numbers here like 80, 70, 60, then we can definitely say this is most common to happen. But here there are no numbers. So we can conclude that ways if it is either more common for which parent to be working because we don't know actually how many mothers and how many fathers are there. Fathers could be like 100. You see this could be 300 and this could be something like 1,000, right? So here if you see 300 times 0.60 would be how much? Well, that would be about how much? I think it would be something close to 200 and wait 180, not 200, 180. And this one I see actually we see 80%. 80% means this should be close to 800. There's like a massive gap. So that means we can conclude. And even if it was 300 here, it was 1,000 here, let's say. That way, totally switch everything. So a 300, if you see 380% out of 300 is how much? It's basically about like 150 and 100. And I think, how much is that? 180, wait, 180 is like 60, okay. 200, 240, 240, 240, yeah. 240. And this one is actually about 600. So actually, in this case, we see far more mothers not working and fathers working full time or common because that is 600. And here is only 240 where both are not working. Okay. So that way we can conclude based on anything of on numbers. We can conclude that it is more common for non-independent to be working hard. We can just say given this or this thing must be true. We can say totally like just directly table relative frequency. We can say just say column relative frequency. We can say column relative. We can say table relative. Okay. Families where the father works full time are more likely to have the mother working full time than part time. Well, actually, here family where the father is working full time, they're more likely to have the mother working full time. No, actually, they are more likely to have the mother is working part time than full time. Yes, but it was actually 0.17. 0.17 is actually less than 0.23. So their mothers are more likely to work part time. They're not more likely to work full time. So C wasn't correct. A is the most likely option. So there are twice as many families where the mother works full time and the father and the father works part time as families where the mother works part time and the father does not. Well, this one actually also we can conclude because we don't know how many families there. So we can say this is twice and this is twice and that. Okay. We definitely know that as many families there's the mother works full time and the mother works part time. So mother is full time, father is part time. That if we see is 0.14. Okay, and then as families where the mother works part time, and that's actually 0.14. But we have to say that a family where the father works part time is twice as likely. Okay, we can't say there are twice as many families. We have to say twice as likely. It's not twice as many. So yeah, that's basically the difference. Yep. Yeah, we only know the relative frequency. We don't know the actual counts of families. We don't know the table relative frequency. We don't know the actual counts. Therefore, this comparison will only be true if the same number of families had father working part-time as had the father working not working, yes. If we had the families at the same number, we knew the number of families, then only we can make this conclusion. Otherwise, we can. We can just say very likely this is more likely than that. We can't say that this is definitely this is twice and that this is twice and that. Like that we can make. We don't know the table relative frequency, right? So yeah. It's more common for neither parent to be working, we can't make. Small female population with the father not working could make this outcome less common, right? Because a small enough population with the father not working, it will actually make this less common. Because if we get more smaller population, then this percentage it really drops. Even though the percentage is bigger, the amount that we get is actually smaller. So that way B is actually kind of incorrect. Doesn't really model this. We just want is column relative, and the column relative we can predict. So yeah. Okay, now this one is the saying is individual data. So Alex is trying inventory of styles of compression managed for work. This is data collected. So individuals data are what styles? Yes, they're compression managed styles. And actually ID is their specific, identification. That doesn't actually count as a variable. The width, total length, and color only counts as the variables, where actually just color is categorical. The other two, total length and width, are actually numerical. They are quantitative. So three variables where one of them is categorical. Perfect. Okay. Nikita knows the following information about a food club that has 11 members. Three like the fruits and vegetables. Okay. Four like fruits and not vegetables, and five members in total like fruit. Why do you help Nikita organize the results into two frequency tables? Sure. Let's organize all the data together. Let's find the relationship between the two variables. Okay. Like fruits and like vegetables. How many like both of them? Well, we don't know. We just know that three members neither like both, neither like. So, if they do not like fruit, they do not like vegetables, we can just say three. In total, how many members like fruit? Well, fine. And then how many like fruit but not vegetables? Four. So how many like fruit? So fruit is being liked by, where's the fruit? Yeah. So like fruit but not vegetables. But not vegetables means here. Okay, do not like vegetables, but they do like fruit. So that is four. And let's say how many members like fruit in all? Five, right? So maybe there's one person who likes fruit. Okay, because that person that likes to has to like vegetables. Because they're saying five people like fruits, five members, and then four out of those five, they should be liking fruits but not vegetables. So the other one would be liking, I guess, both. Because like fruits has to be filled with that. Because otherwise we won't be getting here five. So yeah, that ways we can get here. And now actually we just need to do is 11 members is there in total. So 11 minus 3 minus 4 minus 1. That's how we get 8. And then 8 we get here, and then 8 is actually subtracted from 11, that is about 3. So yeah, 3 may be like vegetables but are not like fruit. In that way, if we add all of this together, so 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 2, 7 plus 4 is 11. So yeah, we get 11 total members. Better than collected data about the kinds of source of past formical lines. Here are some of the data. Now, this one is actually the best description of the distribution box in the column of the row below, table below. So actually, this is giving all of the conditional because this is giving the cats. Now, the cats. They're not saying in total how many cats are there. They're saying if the cat is there, given that the Paris cat, how many of the cats are from the state? Okay, how many cats are from the shelter? How many cats are from the family of friends? We see that should be conditional distribution for the type of pet. So conditional distribution for pet source, yes, pet source of cats. We don't know. Yeah, this is actually not true because we are not getting the conditional distribution for kind of pet for pets from family and friends. If you got like that, should be this part. This is actually this part. So this part means it's actually from the pet source. Okay, it's about the pet source of cats. Consideration for pet source of cats. Yes. Now, Leon is interested in relationship with geographic region, political affiliation. To collect the data about the political parties of centers at the time, in regions that represent the results are shown in the table below, given the constitutional distribution of political party for the Northeast region. Let's give the political distribution for the Northeast region. Okay. So there's the same for this part. In total are 22, and then out of those, how many are this? So 14 divided by 22 and stuff we just want to do here. So 14, 63.6. Near strength of a percentage, 63.6. Okay, now we want to do 7 by 22. I'm sorry, 31.8, right? Yeah, 31.8. And there we go. We have 1, we try 1, it's going 4 right. Actually, we don't want to go much, concentrate on adding the percentages, not. These are just approximate percentages. We can just directly, add them. We can just stack them. We got it correct. Okay, there we go. Okay, now James, same thing again. So James is, kind of all that modeling stuff is doing between the relationship between the train arriving at time or not, if we deal or not, and the weather condition for that day. So basically, marginal distribution for weather conditions in percentages. So sunny, if you see how many sunny did we have? So how many sunny days did we have from the total? So 170 out of 360. Okay, 170 was sunny days. It's kind of sunny, cool weather. It was, I guess, 46.57. So 47. It's actually like pretty low, right? Because most places, if you have, was it like a good climate, it's mostly generally up like up to upwards of 60 plus, 60 plus dead to see, like in the upper 60s. Not in the upper 60s, I think, yeah, up in the upper 60s, like generally we have, like the sunny days. That's like a cool weather, they say. So this one is actually 47, so it should must be pretty cold there for this region. Okay, 120 if you try. 32.87. Okay, 32.87 and 33, right? That should be 33. And we see rainy is 45. So if you try, I'm sorry, okay. Yeah, 15.1. 15.1 or 15. Snowy should be about 8. So 20. For snowy is 20. So for 20, it's about 5.5. 5.5 meaning like 6, I guess. 6 is kind of something. That's it. Oh, okay. Did I have something wrong here? Maybe we should just divide to 5. I think we don't need to, take 5.47, just, make it 5 and stuff. Yeah, okay, there you go. I just, kind of overanalyzation, I guess, is kind of bad here. Let's just take, as it is, just round it and just enter. Okay, Ghana's counselor was curious about the relationship between national transportation and school and whether or not they're working a job in a school. So they're working a job now in school or not. Music class is given here. Following class summarizes the characteristic for the schools from 480 students. Transportation school, private, public, working. What frequency? Some students are working, some students are not. So how many students have a job or not? So well, bulk of students do not have a job. The bulk of the students who actually do not have a job, from them, bulk of the students are actually using private transportation. Public transportation is used by these many students. So actually, the students, who are this guys, have a job, they're more likely to use private transportation, maybe something like, maybe their car, maybe their motorcycle, maybe their, own sort of vehicle, or rather than using public transportation or using walking. And this, without a job, people, they're more likely to, they are actually most often using private transportation, but they generally tend to, gravitate towards maybe like more likely, not gravitate towards, but they were more likely than compared to these yes job students, like those students who have a job, compared to them, those students who do not have a job, they're more likely to use this public transportation or walking. So what you can calculate from here is actually most of the students do not have a job. So majority of students have a job. No, that's not correct. Majority of students do not have a job. Because we see here, this is kind of the way this, more thicker for this no column, no up there, so it's kind of more thicker. For the yes column, if you see, it's kind of more thinner. So yeah, that way we can say that most of the students do not have a job. And if few students have a job and go to school, well, this part is students have a job and go to school and walk to school. Actually, that is correct. You know why? Walking means this part. That is actually the smallest. This part. That's really tiny. So yeah. If your students have a job and you're back to school, that's correct actually. Because if you see from this diagram, what is the smallest, small little box there? That's what we want to see. Music class, we generally, want to focus on box. So the majority of the students in this case actually do not have a job, and they actually use private transportation. The minority, the smallest percentage actually have a job and they walk to school. Okay, these two conditions I mean, those two other conditions I mean. So yeah, that's what we can conclude from here. So now the students with a job are more likely than students without a job to use public transportation. That is actually definitely right. With a job, they're more likely to be because this light blue circle is more bigger, bigger for the CS students. So yes. Because if they are using a job, if they have a job, they're more likely to use public transportation. They will. Anyways, we got them. Okay, awesome. I'm sorry. I'll send here. And then yeah, from the next video, we'll just focus on unit two, which will be on frequency and dot plots. Okay, awesome. So yeah, see you guys in that video.